Hi everybody, this is the first post Kickstarter campaign video. This video is going to talk about the third stretch goal, the component set that allows for you to toggle using the IOs on the learning board as well as the infrared output. There's a special program that I designed for the infrared output because it's a little bit different from other outputs. In any case, we've got two modes of operation. We'll get to that in a second. So let's go over the power supply. You use the regulated 5-volt power supply from the learning board to connect to this component set. I'm going to show you in a minute how to throw this together on a breadboard, but first we'll talk about the schematic. So we take 5 volts VCC from the power supply pin block on the electronic learning board. We'll also splice common ground from the main pin block, and we're going to put 2 capacitors on between the 5-volt line and the ground line to basically add some extra smoothing, because this is a microcontroller. If you have any extra spikes on the line, you don't want to damage the microcontroller. Adding some capacitors here, not overly necessary because we are taking the regulated and smoothed output from the learning board and powering this, but it's good to have it there anyway. So we're doing a ceramic 0.1 microfarad ceramic capacitor, sorry. That's the decoupling capacitor. It's got no polarization. Both leads are of the same size. And we've got the electrolytic, the 10 microfarad electrolytic capacitor. There's a positive side, there's a negative side. The positive side is longer, the negative side is shorter. Again, I'll introduce you to the component set in just a second. Now what you'll notice here are 3 dots. We've got a 3-pin header connector, or header rather, sorry, and if this is our common pin, which is connected to pin 8 on the microcontroller, we can either connect that to 5 volts, which is mode 1, or we can connect it to ground, which is mode 2. We'll get to the modes in just a minute, but that is our selector pin, which is connected to pin 8. Pin 1 is not in use. Now the way to know what the orientation is there's a little notch on the left hand side of the microcontroller. Make sure you pay attention to this because if you hook it up backwards you will fry it. Pin 1 is not used. Pin 2 is our VCC, which is connected to the 5-volt line. Pin 3 is our input. Pin 4 is our toggled output. And the toggle output is whatever logic is on the output is also on pin 5, which is connected to a current limiting resistor and an LED. So if the output here is high, 5 volts, this LED will be lit up. These two outputs follow each other. Pin 6 is not used, hence the little X, pin 1 and pin 6. Pin 7 is the supply ground for the chip, so pin 2 is our positive power supply connected to VCC, pin 7 is connected to the ground line on the learning board. And of course, again, pin 8 is our selector pin. So once we hook this up, it's actually really easy to hook up. We use a 2-pin jumper connector or just a piece of wire. I will be including little headers so that you can solder this to a proto board if you want. They're kind of difficult to use on a breadboard, but if you want to take that extra step, I am including them. So I'll show you the components in just a second, but again, once we have this all hooked up, we have the 2-pin header connector jumping 5 volts to the pin 8, we're selecting mode 1 on power up. If we jump pin 8 to ground, we're selecting mode 2. So let's put this all together. What I did was I soldered this onto a proto board, but I didn't have enough proto boards to include with the stretch goal, so I only included the component set. So I'm going to show you how to throw it onto a breadboard in just a second, but let's talk about the components themselves. The microcontroller is a programmed PIC10F222. On the left hand side there is a notch. Make sure that you know where that notch is at all times, because if you hook this up backwards, I mentioned it before, you will fry it. Here's your 470 ohm current limiting resistor. Resistors aren't polarized. so you can plug it in either way. There are 3 different headers, 2 2-pin headers and 1 3-pin, in case you wanted to solder it onto a proto board. These components won't be very helpful to you if you're using a breadboard, but if you are soldering it into place, you can have one for power supply, one for input-output, and one for mode selection. And there is a 2-pin header connector here that works with the mode selection header. So those 4 components are kind of a bonus. They're an extra. You don't really need them unless you're soldering it to a little proto board of your own. And I would suggest that you do that if you can find yourself a little proto board. They're very cheap on eBay. But I imagine more people might have a breadboard handy. In any case, let's move on. This is your 0.1 microfarad ceramic capacitor. As you'll notice that the leads are both the same size. There's no positive or negative. You can plug it in either way. So one side connects to ground, one side connects to VCC. As for the LED, it is a red LED. And there's a short lead and long lead. Long lead is positive and it connects to the resistor. Short lead connects to common ground. So rather, short lead is your negative cathode, long lead is your positive anode. Lastly, the electrolytic capacitor, 10 microfarad ceramic capacitor. One lead is short, one lead is long. The long lead is your positive, your short lead is your negative. The short lead connects to ground, the long lead positive connects to the 5-volt line. The first thing you're going to want to do is take your microcontroller and place it right on the median here, with the notch facing left. There we go. To the left of the microcontroller, place the ceramic capacitor across the median. On top of where you placed the ceramic capacitor, one lead above, place the long lead of the electrolytic capacitor, and then one pin below where you place the other side of the ceramic capacitor, place your short pin of your electrolytic capacitor. So they're both tied in parallel with each other. Now the pin on top will be where we connect to 5 volts, the pin on bottom will be where we connect to ground. We've got our 2 capacitors in parallel as mentioned before. The 2 leads on the top are connected together, the 2 leads on the bottom are connected together, the negative leads on the bottom. Take one of your female to male wire connectors and connect to the bottom pins, and take another and connect to the top pins. This will be where we connect to our learning board, our power supply. So the positive wire will connect to the 5-volt regulated rail on the power supply pin block of the electronic learning board, and the bottom will be connected to the ground pin, the ground line on the power supply pin block of the learning board. We'll get back to that in just one second. Male-to-male wires do not come with the electronic learning board, but if you have any breadboard wires of your own, I'm assuming that if you have a breadboard, you should have some male-to-male wire connectors. Maybe not like this, but something similar. Anyhow, we're going to connect the regulated 5-volt line to our top rail, and that will mean that anywhere on our top rail will have 5 volts on it. We're going to connect the ground line to the bottom rail. Sorry about this. There we go. So now common ground will be on the bottom here, so we can access it with relative ease. We need to connect 5 volts to pin 2. So now that we've got 5 volts connected to our top rail, I can connect anywhere on that top rail and connect to pin number 2. Alternately, I need to connect pin 7 of the chip to the ground line. And now our chip will be powered once we connect this to the learning board. We're going to take our 470 ohm resistor, connect one end to pin 5, and the other pin somewhere out of the way, like so. We're going to connect the long positive or anode of the LED to the secondary side of the resistor. And we're going to connect the small pin of the LED, the short pin, to the ground line. So now when this LED lights up, our output on pin 4 will be 5 volts. When the LED is not emitting light, the output on pin 4 will be 0 volts. We're going to be choosing mode 1 by connecting the pin 8 to the 5 volt line. We'll be reconnecting this to the ground line later to select mode 2. But remember, we're connecting to 5 volts from mode 1 right now, and mode 1 requires the infrared sensor output. Connect one male to female wire to pin 3, which is our input pin, and we'll be connecting that to the sensor the sensor learning board in just a minute. Let's connect our supply ground pin right here to the ground rail on the power supply pin block, the positive pin, the regulated 5 volt pin, just above it to the 5 volt regulated pin block. I shouldn't say pin block, the power supply pin block is right here, the pins on the bottom are ground, the pins at the top are 5 volts. So now we've successfully powered our breadboard circuit. We'll take our input, because we're working with program 1, we're going to connect it to the IR pin on the lower right of the main pin block. Now let's get a remote control powered on and see if it works. When I plug in my AC adapter, 9 volt AC adapter, the LED should light up once to tell us we're in program 1. And I'll use my remote control to turn it on. I'm using the volume up button, and I'll press it again to turn it off. Again to turn it on, and I'll go get a beer, eat some chips, come back, that'll still be on, I'll press it again, and off. So that's program 1. Now let's connect pin 8 from 5 volts to ground. Connected pin 8 from the 5 volt line to ground, or rather I've disconnected from the 5 volt line, connected to ground, and what I've done is I've taken the input line on pin 3 and connected from the IR pin to the DLY pin, which is the output of the 555 timer. Now, in order to trigger the 555 timer, I've got two options. I can use the in pin, and I can use the sensors and amplifiers on the board to activate it. I call that the software input, or I can just use the calibration button to activate the output of the 555 timer, which will cause a single pulse, and that single pulse will actually be used at the input, which will toggle the output. So instead of just creating a single pulse, we'll be toggling. So let me press the button. Toggled. Let's toggle it again. So from any of the project videos that we've done, we can now use this special circuit to toggle states. Let's press it again and again. So let's connect the relay module and the buzzer module to this. Because of the lighting, we might have trouble seeing the pinout here on the relay board. And this relay board is a bit different than the one I used in my videos. This will be the one that is shipped with the rewards. It's a better quality unit with bigger mounting holes, but it is slightly different in physical size. So there's 3 pins: in, VCC, and ground. VCC is 5 volts, ground is our supply ground, and in is where we want to use the output of our new chip. We'll send the output of our new chip, the toggled output, to the in chip. To the in pin. So to power this, take one pin, connect it to the ground, and connect the other pins. Sorry, that's the wrong wire. Connect the ground using any of the female-to-female wire connections, and connect it to the to the ground rail on the power supply pin block. Take another wire, connect it to the 5 volt line on the power supply pin block, connect it to the VCC pin. Now it's powered. I'm actually going to turn the power off to do the test. And I'm going to take the female to female wire connection, connect it to the in pin, and connect that to pin 4, which is our output. Now I'm going to power it on. Now because the output of the chip is normally low, you see how the LED is off. We're sending a 0 volt signal to the input, and that means that this is an active low relay. So the relay is toggled on Now I'm going to toggle it off. Or I'm going to toggle it off using the button on the board. Now the relay is off. Relay's on. Relay's off. So using this, you can toggle AC appliances on like a lamp, and you could easily use Project 1, the clap circuit, to clap this relay on, clap the relay off. You can use the laser tripwire circuit to toggle the relay on and off. So let's connect the buzzer. The buzzer has a very similar pinout. There's a VCC pin, a GND pin for ground, and an I/O pin in. So VCC we connect to the 5-volt line on our power supply pin block. The GND ground line we connect to the ground on our power supply pin block, and we connect the pin 4 output of the chipset to the I/O pin or in pin of the active buzzer. Now, very unfortunately, I got shipped active high buzzer attachments. So I'm going to need to make some changes to the manual. And I'm going to have to talk to you guys about it because it kind of changes some of the projects around. But it's too late for me to get active low relay buzzers. Active low buzzers. Now, I actually prefer active high buzzers, but this is going to have an impact on some of the project videos, and so I'm going to have to talk with you about that later. But in any case, powered on, I press the toggle button, or the button that sends the signal to the chip which acts to toggle it, and now if I take that protective strip off, it's going to be much louder, but this is much more pleasant not having to hear the really, really loud buzz. So I'll toggle it off. So because it's active high again, when it's fed a 5-volt signal, the onboard circuitry takes care of turning on the buzzer. And it'll stay on for as long as I want until I press the 555 timer button again, the cell button, which turns it off. Now, just to quickly show you one more time the output of the 555 timer, if I connect the output of the 555 timer to my LED on its own, it will create a pulse, but it will go from 0 volts to 5 volts, stay at 5 volts, and then go to 0 volts. The calibration of the pulse duration is adjusted using the DLY variable resistor. Turning it clockwise makes the pulse longer. Turning it counterclockwise makes the pulse shorter. But this chipset is turning that pulse into a toggle. So it's toggling logic. Every time it receives a pulse, it toggles the state of both the LED and the pin 4 output. What I've done is I've just taken the output of the 555 timer, connected it to the LED. This would be the signal we send to the input of the chipset, but now we're just looking at it, now we're just connecting it to the LED right here. And off. So there you go. We can make that pulse duration longer or shorter by adjusting the DOI variable resistor. We have a whole video, we have several videos that actually implement that circuit and talk about that circuit, but I wanted to showcase what this chipset can do. So now let me go through some of the things that I've actually received relative to the Kickstarter. Here are all the chipset kits that I've made, 180 of them. Here are the laser attachments that I've made. I'm not done yet. I've got 100 of them done. I need to do 80 more. I'm kind of halfway through prepping those other 80. To the left are the female to female wire connectors, 10 per set. On the right, the female to male wire connectors, 6 per set. While it's a mess of wires right now, these are the thermistor attachments. I'll be using some twist ties to make them nice and neat when I ship them out. And below them are hundreds of relay modules that are in ESD bags right now. That is the very large bag of buzzer attachments. These are the AC adapters, 120 volts to 240 volts AC in, output 9 volts AC at 1 amp. And the little thing here is the PIR attachment. It's an example of the PIR attachment. Sorry about the focus right now. I'm not using an autofocus camera. Unfortunately, they didn't ship the Fresnel caps, so I'm seeing about that as we speak. Here are the V2.0 boards, the PCBs. I'll be using these to kit. You notice the adjustments. Again, you might have trouble seeing it because I'm not using a tripod. But on the lower left here, there is a THRM pin for the thermistor up here. And here's the RPI jumper, which is talked about in the manual. That's used for interface with the Raspberry Pi. Thanks for watching, guys. I'll have an update soon, and I'll be making an assembly video by the end of the week.